In this video, I'll demonstrate how to solve an equation with two radical terms. We're given the function and asking us to find any t for which the function is equal to a negative 7. So in place of the function notation, we'll put a negative 7 is equal to radical minus radical. And the procedure for solving an equation with two or more radicals is first isolate one of the radical terms. So I'm going to take this negative radical to the other side, which makes it positive. So we have a square root of 8t plus 41 minus 7 is equal to the square root of t minus 1. We'll use the principles of powers, which means we're going to square both sides, which maintains equality with the exception of the possibility of generating extraneous roots. We'll deal with that at the end. Squaring this binomial, the shortcut for squaring a binomial, it is not just the square the first term and square the second. When you have a binomial squared, it is equal to a plus b times a plus b, where we can use the FOIL method, or there's a shortcut where we can square the first term, multiply the two terms together, double that to generate our middle term. It's replacing the O and the I from the FOIL method, and then squaring the last term. And that's what I'm going to do here. Squaring the first term will give us the radicand, 8t plus 41. The middle term will be the result of the product of the first and second times 2. So we'll end up with 2 times negative 7 is negative 14 times the radical 8t plus 41 plus the square of the second term, which is 49. Again, you could write this binomial out as I have up here in the standard form and use the FOIL method. Should ultimately result in this term here is equal to this radical squared. Radical squared is the radicand, the quantity underneath. Next, I want to get like terms together, but we need to simplify first. On the left, we can combine the 41 and the 49 to give us a 90. And there are no other similar terms here. If we still have a radical in our equation, we want to perform the first steps again. We want to isolate this radical. So I'm going to subtract an 8t from each side and also a 90 from each side. The 8t's are gone, the 90's are gone, leaving a negative 14 times the square root of the radical remaining. T minus 8t is 7t minus 1 minus 90, or plus a negative 90 using the rule of subtraction, is a negative 91. Now we're ready to square each side. And I don't think I wrote my negative 7 down. I said it, but I didn't write it down, so there it is. Squaring this term on the left, we have a product. The negative 14 gets squared. Negative 14 squared is 196. The radical squared is the radicand, the quantity underneath the radical. We have a binomial squared here, which means it's a negative 7t minus 91 times negative 7t minus 91. Either use the FOIL method or the shortcut, which is square the first term. Negative 7t squared is 49t squared. Multiply the two terms together, a negative 7t times a negative 91, and double that results in a 1274t. And then square the last term. Negative 91 times negative 91 is a positive 8,281. Mission accomplished as far as radicals being eliminated, but we have a little bit of simplifying. Distributive on the left, 196 times 8t is a 1,568t. 196 times the 41 is an 8,036, is equal to this quantity that we have over here, 49t squared, 1,274t, plus the 8,281, kind of going uphill there. It looks like a quadratic equation. To solve this, let's get it in standard form. So subtracting a 1568t from each side and subtract an 8,036 from each side. We have nothing left on the left. We have a 49t squared, 1,274t minus 1,568t leaves a negative 294t. Combining our constant terms leaves a positive 245. If we can factor out a greatest common factor, it'll make life easier, and it turns out there is a common 49 between all three terms. When we factor out a 49, we're left with a t squared minus 6t plus 5. Factoring that, both signs are the same on the constant term. They're both negative. This will factor into a t minus 1 and a t minus 5, and you can multiply to verify that. Using the zero product property, 49 will not generate a 0, but the t minus 1 will. Solving for t, we get t is equal to 1, or t minus 5 could generate this equation t equals 0, meaning t is equal to 5. Squaring each side does not perfectly maintain equality, and particularly when we have to square two different times to eliminate the radicals, there's a chance that we could generate an extraneous root from this not quite equivalent procedure here. So test these values into the equation and see if they work. So if I let t equal 1 in that original equation, and let me slide this back up here, we would have 1 minus 1, the square root of 0 is 0. Letting t equal 1, 8 times 1 is 8, plus 49, or 41 is 49, the square root of 49 is 7, and we would get the negative 7. So the t equal 1 works, and if you replace t with 5, you will find that it works as well. So our solution set will be both 1 and 5 for this problem.